Happy Monday before break, everybody. So today we're really going to focus on one idea that people have asked about a few times now. And it's how do you come up with the A value without trial and error? So previously I had you figure out the vertex or the x-intercepts and then kind of experiment until you got the correct value for A. So today we're going to look at how do you solve for that without having to guess. And so we're going to look at a case with each type of, or each quadratic equation format. There we go. All right. And the way we do that is once we know all the other values in the equation, really we can take any point from the parabola. And I really want to emphasize that you can take any point and then solve for the A value. So let's take a look one step at a time. So the first case is in factored form. And notice how I have A sitting here. My question is, what is that? But I've given you this point. So in this case, remember a point is x, y. And so over here, notice how we have a y, we have an x, and we have an x. So in other words, and if you like, we can always kind of do our triangle square piece if that helps illustrate. Where this is square, triangle. So in other words, we're just saying that where y was, there should now be a -6. And where x was, there should now be zeros. And if you look, the only remaining variable is a, which we should now be able to solve for. Zoom in a little bit here. Cool. And so now, in other words, we still have a -6 because we've got two sides of our equation. We've got a. So now order of operations tells us to deal with what's inside the parentheses if we can. Well, I'm pretty sure we can do 0 minus 1, which would be -1, and 0 plus 3, which would be +3. All right, and remember, this is all multiplication. So a times -1 would be -1a times 3 would be -3a. And in other words, we now have -6 equals -3a. And from here, my last step is to divide by -3. -6 divided by -3 will be +2. So that must be my A value. So if I go back to my original equation, A is what I was trying to look for. So then my final equation with A solved for, must be this. So that's all that's going on. You're just like we used to solve for things with the equation of a line, we're doing the same thing here. So take a point, replace x and y in the equation, solve for A, and then we have our final equation. And you don't have to take my word for it. We can go take a look at the graph. And if you notice, I entered in the equation, the point, and sure enough, that parabola goes right through that point. All right. So let's take a look at a second case. So we're going to take a look at parabola 2. So if you notice, we've now got one in vertex form. The vertex form works very, very similarly, but you just got to be careful because order of operations is going to be a big deal because we've got parentheses with an exponent outside of them, then with multiplication, and then with addition. So we can do the same thing. You know, here is xy, or if you want to think square triangle, that's great. So in other words, got triangle equals A times. All right, and this time my x value happens to be 2. And my y value happens to be -1. So I'm just going to start simplifying. I know order of operations says deal with inside parentheses first if you can. So we'll leave that. A, I see 2 minus 1 is 1 to the second power. 1 to the second power is nice because that just means 1 times 1, which will just be 1 in this case. So I'll end up with a times 1, or just 1a, plus 3. And now I'm one step away. And here I'm getting that a should be equal to -4. It's technically 1a, but remember, if I see 1 times a, it's just a. You could divide both sides by 1, but nothing would change. So if I clean that up, yeah, you'll just end up with a equals -4. So once again, I'm just going back up here, and I'm saying that I now know that a is -4. And there we have it. And take a look at the graph. Sure enough, if I put a -4 in front with that point to -1, that parabola matches that point perfectly. All right, and now finally we'll take a look at a third example. So this one is in standard form. And once again, we've got some order of operations issues that are going to present themselves potentially. So once again, here's xy, or box triangle. So in other words, all right, the key is, remember, that's a times whatever goes there. All right, so I know that wherever an x is, that's going to be 5. So I've got, sorry, I forgot my exponent. And wherever that triangle is, that's my y value. All right, so there I have it. There's a lot going on here. So the first thing I'm going to deal with is right here I have a times 5 to the second power. So remember, exponents are one of the early operations. So 5 to the second power, that's going to be 25. So a times 25 will be 25a. And then I have plus a 6 times 5. So that'll be plus 30. And then I have this minus 2 on the end. All right, if you take a look at this side, a is here. Not much I can do with that term, but I can simplify this. I have 30 minus 2. So that's going to be 28. Now I'm solving for a, so I'm just going to subtract 28 from both sides to get that -25 equals 25a. So if I divide both sides by 25, I'm going to get that a equals -1. And if a equals -1, then I'm going to go back up to my original equation here, and instead of a, I'm just going to say -1 x squared plus 6x minus 2 must be my equation. Because once again, we solve for that a value. And let's take a look at the graph one last time. Sure enough, when -1 is in front of that x squared term, it goes through 5, 3. So that's all there is to it. You just got to take your format. You got to replace x and y with any point. In this case, I only gave you a single point, but if I gave you 10 different points, you could use any of the 10, and they would all get you the correct a value. So for today's assignment, you're just going to play with that idea. Please reach out if you have questions. And otherwise, have a wonderful day.